In the previous video, we figured out how to rig a 2D bouncy ball using empties. In this video, we're going to recreate that rig, except we're going to do it with an armature. But why? Why go through that effort? Well, to be honest, we should have rigged it with an armature to begin with. But I'm trying to introduce concepts one at a time, and armatures are a large and complex topic. So to start off, let's take a brief look at the advantages of using armatures, and why we would want to use them for rigging. The most obvious reason is actually one that doesn't apply in this simple case, but I'll point it out anyway. Blender has an armature modifier that allows you to deform meshes with multiple bones, and Blender has no such modifier for multiple empties. Again, this isn't relevant to the 2D bouncy ball, but it becomes important when we start rigging characters with contiguous deforming meshes. Another reason to use armatures is that they give us a lot better control over the transform spaces of our controls and rig mechanisms. So, for example, it's trivial to set a custom zeroed out position for a bone, whereas that's much trickier with objects. And this control over bone spaces turns out to be important, as we'll see later on. Another reason to use armatures is that there are some important constraints that are only available for bones, such as the inverse kinematics constraint. There are also two production-oriented reasons for using armatures, which don't really apply so much if you just plan on building and animating a rig in one blend file, but they're very important in a larger production with multiple scene files. The first of those is that Blender's animation data is stored in something called actions. Whenever you animate an object, that object gets an action that stores its animation data. Unfortunately, if you have 50 rig controls that are all separate objects, that means you're going to get 50 separate actions when you animate them. And that is not only an organizational nightmare, but it also makes the animation nearly useless for Blender's nonlinear animation system. If you use an armature, on the other hand, the whole armature just gets one single action. The second production-oriented reason for using armatures is that armatures are the only object type in Blender that you can still fully manipulate if you link it into another scene. If you plan to use the same character rig in multiple scenes, that's kind of important. You don't want 50 copies of the same rig for 50 scenes, you just want the scenes to all reference the same rig and put different animation on it. Armatures are currently the only way to do this in Blender. So that, in a rather large nutshell, is why you want to use armatures to build your rigs. But armatures are kind of a strange beast. They're objects that contain something called bones, and these bones are kind of halfway between being like vertices and edges and being like empties. Bones can be edited in a similar fashion to meshes, but they can be posed in a similar fashion as objects. In short, they are a confusing conundrum. But let's see if we can't make them a little less confusing by actually using them a little bit and demoing how they work. To start, let's add an armature. By default, an armature starts with one bone. To edit the armature and add more bones, we have to go into edit mode, so hit tab. In edit mode, we can select the bone's endpoints, which are kind of like vertices, and move them around. We can also select the whole bone and move it around, but in edit mode, bones are defined by the locations of their endpoints. While in edit mode, we can also add more bones to the armature by hitting Shift A. In short, edit mode is where you add and place bones in the armature. To use these bones for animation, however, we need to go into pose mode. To do that, hit Control Tab. In pose mode, the bones no longer behave like vertices or edges. Now they behave a lot like empties. Instead of being defined by the position of their endpoints, they are now defined by transforms, location, rotation, and scale, just like empties. In pose mode, you can also lock bones transforms, just like with objects. And you can add constraints, also just like with objects. In short, in pose mode, bones behave like objects. The only object-like thing that you can't do in pose mode is parenting. To parent bones to each other, we have to go into edit mode. Notice that with bones, the parenting menu has two items, connected and keep offset. Keep offset is the normal parenting behavior that you're used to with objects. So let's select that for now. I'll explain connected later. Notice that parenting has no effect on the bones in edit mode. You can still move a bone's endpoints around freely without causing the bone's children to move with it. But if we switch back to pose mode, then suddenly the parenting has the expected effect. You might wonder why edit mode exists at all, and you would be smart for questioning that. After all, why not just let users add and parent bones in pose mode? The main purpose of edit mode is actually to determine the default rest positions of the bones. So for example, if I select this bone here, we can see that all of its transforms are completely cleared, and yet it's not at the origin position, nor does it have cleared rotation. That's because of how we positioned the bone in edit mode. Wherever a bone is placed in edit mode, that is its default zeroed out position. And this is useful for several things, not the least of which is allowing the animator to clear transforms on rig controls without worrying about it collapsing the whole rig to the origin. So that's a basic overview of armatures. And with that overview out of the way, let's dive into rigging the ball with an armature. The process is going to be almost identical to how we did it before, except we just need to be mindful of edit mode and pose mode. Therefore, I'm going to glaze over the stuff that we've already covered and focus on what's different. Let's start by adding an armature for the rig. Make sure its transforms are cleared, and name the armature rig. Also, we want to be able to see the bones inside the ball as we're working on the rig. We could switch to wireframe, but I prefer to set the armature's draw type to X-ray. Go to the object properties, find the display panel, and toggle on the X-ray checkbox. Yay! Now we can see the bone. When we rigged the ball with empties, we let the ball itself be the spin control for the rig. But when you rig with armatures, you want all of the rig controls to be inside the armature itself, so that all of the animation for the rig will go into one action. That means the ball can't be a rig control anymore. We are making the rig with an armature now, so the spin control needs to be a bone. Now go into edit mode on the armature, and position the bone to be the ball's spin control. And name the bone's spin. Now go into pose mode and select the bone. You may notice that the rotation transforms on the bone actually has 4 components. That's because bones, by default, are set to use quaternions to represent their rotations. Quaternions have some important advantages when dealing with 3D rotations, and I'll explain them later on. But for 2D rotations, it's much better to use Euler rotations, which is what objects use by default. We can change the bone to use Euler rotations by clicking on this drop-down menu and selecting the XYZ Euler rotation mode. Now let's figure out which axis to spin on. Looks like it's the y-axis again, so lock the other 2 axes along with the rest of the transforms. Now we want to attach the ball to our spin bone. When you're in pose mode, you can still select objects outside of the armature as well. So select the ball, and shift select the bone, and hit Ctrl P to parent them. The menu that pops up is quite imposing. Remember when a menu popped up when we were just parenting objects, even though it only had 1 item? Well, this is why that menu exists. When you're parenting an object to a bone, there are many ways to do it. I'll just explain 2 of them for now. The first item on the list, object, means that you want to parent the ball to the armature object, not the bone. If we did that, then the ball would move if we moved the entire armature object, but not if we moved the bone. That's not what we want. The last item on the list, bone, is what we want. That will parent the ball to the bone we have selected. So, select bone from the menu. Now when we move the bone around, the ball moves too. Hooray! Next, let's create the counterspin bone. Go into edit mode on the armature again. Select the spin bone and hit Shift D to duplicate it. And let's move it to the side a little bit so that we don't get confused between the 2 bones. We'll move it back later. Let's name the bone MCH Counterspin. The MCH is for our own convenience as riggers, so we can tell at a glance that it's a mechanism bone, not a control bone. And the rest of the name describes what the bone is for. Let's drag the tip to make the bone a little smaller so we can distinguish it from the spin control bone when we move it back later on. And let's make it the parent of the spin control bone. Finally, let's create the main control bone for squash and stretch and location control. Position it at the center of the ball. name it main, and make it the parent of the MCH counter spin bone. Now switch to pose mode again, because we need to lock the bone's transform axes and add constraints. Add a maintain volume constraint to the main control bone. One of the nice things about bones is that their long axis, the one between their endpoints, is always the bone's local y-axis. So we know right off the bat which axis is the axis that we want to be free for the squash and stretch. However, if we go to the constraints panel, there aren't any constraints there. Hey, what's going on? We just added the constraints. That's because bones aren't objects, and this constraint panel is for object constraints. The constraints for bones are in a different panel here. Ah, there the constraint is. Awesome. Okay, now let's configure it. Oh, nice. Okay, well the y-axis is already the one that's set to be free. Well, we don't have to do anything then. But we do still need to lock the x and z scale axes on the bone. Now if we scale the bone, squash and stretch, yay. Okay, sweet. And now we just have to lock the rest of the axes we want on the main control bone, just like when we were using empties. Now all we have to do is set up the counterspin driver. But before we do, let's take a look at what happens when we rotate the main control and the counterspin bone. Select the main control and rotate it to the right. Notice that it rotates on the z-axis in the negative direction. Now rotate the counterspin bone to the right as well. This bone rotates on the y-axis in the positive direction. How weird. What's going on? What's going on is that rotations on bones take place on their local axes, which are defined by their orientation in edit mode. So this means we want to drive the counterspin bone's y rotation with the main control bone's z rotation. It also means that the same rotation direction is positive on the counterspin bone and negative on the main control bone. So we don't have to make the driver negative like we did with the empties. It's already built into how the bones are oriented. So let's add the driver and start setting it up. I'll skim over this since we already did it once, but there is one thing I need to point out partway through. Okay, here's what I wanted to show you. With empties, we could just specify an object for the variable to reference. However, with bones, you have to specify both the armature that the bone is in, and then the name of the bone itself. And that's because different armatures can contain bones with the same names. So the name of the bone may not be unique. You have to tell Blender which armature the bone is in as well. So specify the armature object first, which we named rig, and then give it the name of the bone in the next field. We also need to tell the variable to use transform space. For now, just accept that we need to do that. The rest of the driver setup is exactly the same as before. Okay, cool. Well, now let's give this little rig a try. Oops, that's kind of a weird wobble there. What's going on? Well, what's going on is that we need to move the counterspin bone back into position. Remember, we offset it from the spin bone. Make sure you do it in edit mode, not in pose mode. And let's also move the counterspin bone to another layer. Remember that armatures have their own internal layer system, so we're moving it to another layer of the armature, not a layer of the scene. Select the bone, press M, and move it one layer down. Now it's hidden and out of our way. If you want to toggle the layer to be visible, go to the armature properties and find the skeleton panel. The armature layers are here. You can toggle them on and off by shift clicking, but I'm pretty happy with that mechanism bone being hidden, so I'm going to leave it alone. We now have a functionally complete ball rig. Look at that. But there are still a couple of things that we can improve. The first is that we can move the main control down to the base of the ball. This is a good idea because the ball will often be squashing against something. Let me show you. Go into edit mode and move the main control bone down to the base of the ball. Remember that you don't have to worry about it dragging its children with it when you're in edit mode. Now when you scale it, it squashes against the ground. This reduces work for the animator, who would otherwise have to scale and move the control to accomplish this. The second thing we can do is make the controls prettier. The default bones appearance don't look all that nice, and moreover, they don't do a good job of communicating what the controls are for. One of the cool things about bones is that you can give them a completely custom look simply by telling them to imitate the look of another object. So for example, if we add a monkey head to the scene, we can make the main control bone look like it by selecting the bone in pose mode, going to the bone properties, and finding the custom shape field in the display panel. All we have to do then is click on the field and select the object we want the bone to imitate, in this case, monkey. Ta-da! The bone now looks like the monkey head. Notice though that it isn't in the same orientation as the monkey head. That's because the bone moves, rotates, and scales the shape of the object to match its own transforms, no matter what the transforms on the object are. This means that to change the appearance of the bone, you have to actually edit the mesh in edit mode. You can't just move the object around. Of course, a monkey head is not what we want our controls to look like. Fortunately, I have pre-made some shapes for us on the last scene layer. I've named the one for the main control WGT main, and the one for the spin control WGT spin. I use this naming convention so that it is easy to tell what bones the shapes are for, and so that I know they are for a distinct purpose compared to the other objects in the scene. Let's assign them to the bones. Select the main bone, go to the custom shape field, and set it to WGT main. Oops, the bone seems to have disappeared. But in fact it hasn't. What's going on is that the object we used for the custom shape only contains edges, not faces. For those edges to be visible, we have to set the armature to display wireframe. Go to the object properties, and in the display panel, change it from textured to wire. Yay, it's back. Now assign the shape for the spin bone. Awesome. You might notice that I built these shapes to be outside of the ball mesh. This is on purpose, because now we can turn off X-ray display. X-ray display can be quite confusing with more complex rigs, as controls overlap with each other. So I try to design my bone shapes so that it is not necessary to have X-ray display on. Finally, we have a completely finished rig. Good job. Now maybe we can move on to something other than bouncy balls.